Okay, continuing on, I look at part B and I notice that the right side looks a lot more complex than the left side to me, so I could write this as cosine of A over cosine of B, cosine of A. You know what I mean? Over cosine of B over sine of B plus 1 over 1. And this is the cosine of B over sine of B minus cosine of A over sine of A. And I notice here the LCD for the top and the bottom combined would be sine of A sine of B. So this is not missing anything here. I'm going to multiply sine of A sine of B top and bottom. I'm going to multiply sine of A both top and bottom. Here I'm going to multiply sine of B top and bottom. And from what I know, I'm going to ignore the denominators because they all have it. This is a complex fraction, so the top will have simply the cosine of A cosine of B plus sine of A sine of B. So the top is nothing more than cosine of A minus B. Remember, that's the opposite. As for the denominator, I'm going to have the sine of A cosine of B minus sine of B cosine of A. And if you recall, that's the sine of the first angle minus the sine of the second angle. And cosine over sine of an angle is the cotan of A minus B. And that pretty much proves that identity. Next problem. Left side, of course. This is the sine of x cosine of pi over 2 minus sine of pi over 2 cosine of x. This is the sine of x cosine of pi over 2 is a 0. Sine of pi over 2 is a 1. That is 0 minus the cosine of x. That's negative the cosine of x. And that's pretty much it. As for this problem, I'm going to work with the left side. I know what that is. That's the cosine of the first, cosine of the second, minus sine of the first, sine of the second. A plus, this is cosine of the first, cosine of the second, plus sine of the first, sine of the second. Those two cancel out. One of those plus one of those is two of those. So even though this looks very long, the looks could be deceiving. Now the last aspect of this section, and that's tell me what the sine of A minus B is. Well, I know that's the sine of A that's the sine of A cosine of B minus sine of B cosine of A. So I need those four values. And the way it works, cosine is negative and sine is negative. I know the triangle is in the third quadrant. I am going to ask you to sketch the graph of the triangle. I'm going to say find the exact value of each expression. Make sure to sketch the triangle. Adjacent over hypotenuse, that's negative. And in this quadrant, y is negative the square root of 8 or negative 2 radical 2. I'm going to do the same right here for b. b, it says the tangent is negative and cosine is positive. My triangle must be in quadrant 3. There's beta. Opposite over adjacent. We know y is negative in this case. And this is the square root of 26. Now I am going to shift this a bit to the right. And you figure out what I need. Out of A, I need sine. Sine is the opposite over the hypotenuse. And I need cosine. And out of B, I need cosine, which is 5 over radical 26, and sine, which is negative 1 over radical 26, which would be, and again, excuse me, no need to rationalize, that's going to be negative 10 radical 2 minus 1. And there it is. A couple more to go. If I look at this problem, I would say this is the sine inverse tangent. We said that was negative pi over 4 from where does cosine equal 1 at pi. This is the sine of 3 pi over 4. I know the value is radical 2 over 2. Is it positive or negative? 3 pi over 4. In the second quadrant, we're all positive. And if I looked at this problem, I say, wait a minute, that's not a standard angle, call this theta. That's not a standard angle, call this beta. I'm looking for the tangent of theta plus beta. That is tangent of theta plus tangent of beta divided by 1 minus tangent of theta tangent of beta. And again, you just filling in the values is acceptable. You get me that far, me and you are very happy. I'm going to go here and figure out a couple of things. First things first, I noticed that this is in quadrant 4. Why is that? Because inverse sine is negative in quadrant 4. There's theta. Theta is the opposite over the hypotenuse. That makes this the square root of 8 or 2 radical 2. Out of theta, I need two values. I need tangent, which is negative 1 over 2 radical 2, negative 1 over 2 radical 2. And I want from beta, I got beta to equal the inverse cosine of negative 1/4. That means cosine of beta equals negative 1/4. That triangle must exist in quadrant specifically 2 because inverse sine is negative, cosine is negative in quadrant 2. It's the adjacent over the hypotenuse. That makes this square root of 615 positive. And out of beta, I need two values. I need the tangent of each. Tangent is the opposite over the adjacent. And that's sufficient. One more to go. And this is a problem that we need for calculus. We call this theta. We call this beta. Just like the problem I did. So I'm really looking for the sine of theta plus beta, which is the sine of theta cosine of beta plus sine of beta cosine of beta. So out of theta, I need two values, and there's theta. If theta equal the inverse tangent of x, that means the tan of theta must be x over 1. My triangle, if it's variables, that's good news because you're always in quadrant 1 unless they state otherwise, and they won't. This is the opposite over the adjacent. Opposite over the adjacent. This is the square root of 1 plus x squared. I need two values out of that. I need sine and cosine. Sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. And as far as beta is concerned, I let beta equal the inverse cosine of y, which means cosine of beta equals y over 1. Again, this is needed for calculus, second semester to be specific. And the beauty of those, they're always in quadrant 1. This is the adjacent over the hypotenuse, so 1 squared equal y squared plus, call this L squared equal 1 minus y squared, and L equal plus or minus the square root of 1 minus y squared. So in this case, this is positive because I'm in quadrant 1. And what I need, cosine is the adjacent over the hypotenuse, and sine is the opposite over the hypotenuse. That's good enough. You could leave it like that, I don't mind. And that pretty much concludes this section.